Hello everyone, my name is Ali Hantal. I am the co-president at OpenAir Cloud, adoption officer for the Geopose Standards Working Group at the Open Geospatial Consortium, and the CEO of XR Masters, the creators of the MyGeoverse platform. Today, I'll be talking about OGC's Geopose and Points of Interest standards and demonstrating how these standards are used to create an open spatial web platform for mobile and WebXR clients. As developers, we've been working with the Open Web Platform for over 35 years, a collection of standards and protocols that has proven to scale remarkably well. Taking inspiration from this, we envision a future where the spatial web is open and interoperable, where digital content is persistently and precisely anchored to real-world locations and accessible across different devices and platforms. We call this the Open Spatial Web Platform. And this is exactly where the Open Spatial Computing Platform, OSCP, comes into play. OSCP is a reference implementation that enables geospatially anchored experiences through open standards and open web technologies. It provides the infrastructure for persistent AR content, collaborative mapping, 6DoF localization, and geospatial queries. In simpler terms, OSCP allows applications to augment the world with persistent, interactive, and shared digital objects, much like a real-world counterpart to the web as we know it today. Let's walk through the sequence of how the Open Spatial Web Platform works. You start with spatial clients, devices like smartphones, smart glasses for audio AR, or AR headsets that connect to the cloud. The client sends its coarse location to the Spatial Service Discovery System, which then returns a variety of relevant services. The client can now request a geopose by sending an image and other sensor data to a VPS, Visual Positioning Service. In return, it receives an accurate geopose. Its precise 6DoF position and orientation in the real world. With that geopose, the client can now request additional services, stream its geopose data to the cloud, and subscribe to other spatial services. One critical capability is discovering content packages and experiences in your vicinity. Whether that's 3D models or points of interest, these content elements are geo-anchored and associated with your geopose. Once content is discovered, traditional web technologies can be used to download and display it on the client device. This architecture demonstrates a client-server model where spatial services are decentralized and context-aware. Operating closer to where you are, delivering data that is directly relevant to your surroundings. And with this, devices in the physical world can truly start leveraging the power of the open spatial web. And that's exactly what we demonstrated yesterday at the Google campus in Mountain View during the W3C Immersive Web face-to-face event. We had one publisher platform, the MyGeoverse platform created by XR Masters, and two mobile clients. The first client was the MyGeoverse native mobile app, which was used to author the content, a 3D OGC logo, and a point of interest. It immediately went through the full OSCP sequence after authoring and localized again using Augmented Cities VPS and then discovered both the logo and the POI, which were published in compliance with Spatial Content Record Standards. The second client was the Sparkle WebXR client developed by OpenAI Cloud. It also followed the same sequence, localized using Augmented City VPS, which is compliant with OG standards as well, and successfully discovered the same logo and the point of interest. So why create a WebXR client? It runs in browser, no need to install anything. Triggering AR experiences becomes very easy, seamless activation, and universally browsing various types of digital content. And at OpenAI Cloud, we created a fully open source WebXR client for the OSCP. We call the app Sparkle. As I mentioned, actually this is by OpenAI Cloud, and would like to provide a disclaimer that the Sparkle is not a product, but instead a research prototype, and some of the features are only experiential. However, by scanning this code, you can actually experience Sparkle yourself. And there are the links here, which we also provide at the later phases and in the slides. Actually, the good news is you can also try it yourself. If you go to building 43, in front of that building on the Google campus, and stand in front of the entrance, then turn to your right and point your phone toward the trees right there, and you will be able to localize against the point cloud digital twin using the Augmented Cities VPS. I actually went there and scanned it previously so that it is VPS enabled. And once localized, you will see both the 3D OGC logo and the point of interest appear right there in the real world. And even better, if you visit the location yourself, you can install the My Geoverse app, available on both Google Play and the Apple App Store. You can download the app on the QR code shown here. With the app, you can author your own content right at the location. Then, using Sparkle, a completely separate WebXR client as I mentioned, you can try to localize again and view the content you just authored. This demonstrates the power of an open, standards-based spatial web, where different apps built by different developers can seamlessly interoperate through shared geospatial infrastructure. And here's the demonstration video. Welcome to the demonstration of an open and interoperable spatial web experience, leveraging Geopose compliant localization, open standard POIs, and seamless AR content discovery across multiple clients. This is the My Geoverse platform, My Geoverse app, and now I am localizing against Augmented City VPS. I am localized now, and I am going to place GLB content, which is an OGC logo, and I can rotate it, and I'm just going to place it right here. Now, the next thing I'll do is I will create a POI, and that POI will be right here, and that's going to be the fire hydrant. And here you go. I am now, I just created a point of interest as well as GLB content here. Let's localize again. And I can see exact logo right there along with my fire hydrant. This is Sparkle WebXR client. uses Augmented City as VPS again, which is OGC Geopose compliant. And now we are going immersive with our WebXR client. I'm localizing against point cloud using Augmented City VPS, and as you can see, it successfully localized and was able to discover the OGC logo. Now we're turning around to see our fire hydrant point of interest as it was placed accurately, as it was placed where right next to it. Thank you very much for watching the demo. And this is the end of my presentation. You can actually receive all that information if you scan this QR code, it'll take you to a web page that I'm showing you on the right. You can learn about all the standards and protocols and watch the same video. And again, if you go to that location, you can find all the information on this page, how to run this demo yourselves. Thank you very much. And remember, everything has a geopose. Even you have a geopose. Thank you very much and have a great day.